Alright, so in this last video, we're going to prove the limit as x goes to 0 of e to the x equals 1, right? So first, we want to take, remember, we have absolute value f of x minus L is less than epsilon as our definition. Our function is f of x equal to e to the x, and our limit is 1, okay? So e to the x minus 1, and then we want that to be turned into x minus c, where c here is 0. So x minus 0 is less than some delta, okay? So first we start with our scratch work. So we start with f of x minus L less than epsilon, and we're trying to turn it into x, absolute value of x less than delta. That's the goal. So first thing I'm going to do is I'm going to use algebra to break this up into minus epsilon plus epsilon. And now I'm going to try to start solving for x. So I'm going to add 1 to all sides. And so I have 1 minus epsilon on the left and 1 plus epsilon on the right. Now to get x by itself, I need to do the inverse of e to the x. That's the natural log. So I natural log all three pieces, and to get rid of e to the x, that just becomes x now. And I have the natural log of 1 minus e, and I have the natural log of 1 plus e, where my e here I'm saying is epsilon, not the transcendental number e, okay? So one thing that we know about epsilon, if epsilon is strictly less than 1 but greater than 0, now all of a sudden we have a number in here that is actually, if you think about it, you subtract epsilon, that's 0 less than 1 minus epsilon. Look, the natural log is only defined for numbers that are greater than 0, okay? So the number has to be greater than 0. So that's why we need to restrict this. Now the problem with epsilons that are between 0 and 1 here is that this output now is always negative, okay? And that's what we're saying right here. So in order to wrap around that, I'm going to consider the absolute value here, because we think about delta. Delta needs to be a positive number. So if I take the absolute value, then I'm good to go. All right? So what do? I want to choose the minimum of the deltas, because remember, like my form, I want x minus 0 less than delta, right? That's what I was going for here. And so right now where I'm set up at is x minus 0 less than delta, and then greater than negative delta, okay? So my negative delta here and my positive delta here. So what I need to do is I need to figure out which is the smallest of the two deltas. Is this one smaller or is that one smaller? Well, it turns out that this second one here is the smaller of the two. Why is that the case? Well, let's work through the logic of this, okay? So what do we know that this is equal to? Well, since this piece in here is always negative for epsilon between 0 and 1, then by definition of absolute value, this is equal to the negative of this here. And if you are having trouble remembering absolute value function, it's defined to be a piecewise, which is x for values that are greater than or equal to 0, and it's negative x for values of x that are less than 0. Since we know that this is always less than 0, then I'm in the second case here, So I have to put that negative out front just like I did there. Okay? So if that's the case, then what do I know? I know that this is less than that right there. Okay? And through properties of logarithms, if I have a negative 1 out front, then this comes up to the exponent here, the power rule. And now I can use my reciprocal here. This becomes that right there, natural log on both sides. But guess what? If I do the e on both sides, which is perfectly fine to do, then it gets rid of my natural log. So that's what happened there. And if I multiply both sides by 1 minus epsilon, which is fine to do, we know what about epsilon? We know it's between 0 and 1, so it's still going to be, this is a positive number, so our inequality doesn't swap around. Therefore, if I do 1 minus epsilon times 1 plus epsilon, what do I get? I get 1 minus epsilon squared, difference of squares. Okay. And so this is true for epsilon. Clearly that's true for epsilon between 0 and 1. Okay? So we have established this identity here for my delta. So where do I start? I start with my delta, and so I start with x minus 0. So now we're to the formal part, so we're past the scratch work, so we're going to the blue formal part. So I start here, and then I finish here. And so what is delta equal to? Well, what do we have here? We have definition of absolute value. Delta is equal to what? Delta equals natural log of 1 plus epsilon. So I have a 1 plus epsilon and a 1 plus epsilon and negative natural log over here. Okay. And so what am I going to do? Well, I need to fix this a little bit because guess what? This does not match what my scratch work over here does. And in order for me to get to this next step here that I can write down here, I need to be able to link a connection between this expression here and that expression there. Namely, I need this one to be bigger than this one. Okay, so I've got to prove that. Well, I'm going to prove it with this information that I have over here. And so once again, I'm going to factor this out. I'm going to divide both sides by 1 minus epsilon. And then I'm going to rewrite the rule. See, I'm literally going in the opposite steps of what I had here. And once I rewrite the rule, I natural log it. So look, guys, I'm literally like this step right here is that step there. This step here to get to here is that step there. We just skipped a little bit. Okay. And so what do I know? Well, the exponent rule, bring power rule, come out front like this. And we are very close to relating these two things right here. What's the difference here? What's the difference between this and this? It's a negative. So what am I going to do? I'm going to take this and I'm going to put it over on the other side to make it negative. Okay. And then I'm going to take this, I'm going to move it to this side. So I'm going to add it to both sides. And now I have an inequality where, look, I know that this thing right here is greater than this right here. So I can write I can write this right here, right there, by inequalities. And so now I have my setup that I was looking for right here is established right there through this algebra right here. Okay? And so what can I do? If I E all three of these, then I get e to the x in the middle. E to the ln cancels the ln's. And so I get 1 minus epsilon and 1 plus epsilon. And now I'm going to add or subtract 1 from all pieces. And so I get epsilon and negative epsilon. And so this sets up for my absolute value of e to the x minus 1 is less than epsilon, which is what is desired, and that is the end result of my proof. Now I write it out formally. I say, therefore, given some epsilon. Now I had to put a restriction on epsilon here. I put the restriction on epsilon here, so I need to write it down just like I did whenever I had delta restrictions. And I choose my delta to be the natural log of 1 plus epsilon. Therefore, this then implies if I have x minus 0 less than delta, that implies that absolute value of e to the x minus 1 is less than epsilon. And that concludes the proof that the limit as x goes to 0 of e to the x is equal to 1. All right, guys, I'm going to zoom out so you can kind of see that whole proof in one shot. Okay.